Okay, let me add this person. Okay, so recording has started. So welcome to today's tutorial. We're going through the semester test 3 2022 one. So we'll start as usual with the design pattern. So with the design patterns, right? It's kind of tricky to find which one to use, but I would advise you when you're reading the slides, né, and you're looking at each design pattern, I want you to focus mainly on where it says when to use. That's very important, and the short description that it talks that talks about the design pattern. You need to look at that short description because sometimes these design patterns are similar. Like I think most of the case in any problem you solve, there will be two design patterns that you can use. There's one that is, let's say 80% applicable. It can be used as 80%. It's 80% correct. Then there's one that's always 100% correct. So I don't know how you get to 100%, but as long as if you can get at least one of those two design patterns, I think you should be okay. Your employer has tasked you to design a game where a hero is trying to avoid monsters while collecting coins. When each monster enters the screen, they are added to the list of monsters that are observing the hero's health. You see, here they kind of gave you the hint. They use the word observing, right? So clearly it's the observer design pattern. If you remember last time when we looked at it, I didn't have to scroll down to know it's an observer because I understood the problem. When the hero's health changes, the monsters must also update their state. That is, decrease speed if if the hero is healthy, or increase the speed if the hero is hit. When a monster leaves the screen, it is removed from the list of monsters. Some code has been compared. They didn't. Sometimes they might give you a different scenario. They put it in a different way. But the observer design pattern, right? The way it works is that it's like the way I view it, right? It's like YouTube. That's how the observer design pattern works. It's like YouTube. You have subscribers, which is those subscribers, in this case, we call them observers. They observe something. What are they observing? Your YouTube channel. So your YouTube channel, in that case, it's the thing that, in other words, we can say that's the observable. If the observer design pattern had such a word, we would say that's observable, the thing that we are observing, which is the YouTube channel. In this case, the observer design pattern, it calls it the subject. So that's the subject, that's the thing we're observing, right? Or you might not understand why they chose subject. For example, in school, when you do a subject, don't you guys learn the subject? And don't multiple people observe that subject or learn that subject? They do, right? So I think that's kind of where they got the term subject. It's just a personal preference. That's the word they chose to use. They could have used the word observable. That would still be fine. But I think they're trying to make this design pattern unique in its own way. But at the end of the day, it's kind of similar. So, okay, we have hero. Okay, we have that. Okay. So we have this enums. Yeah, there's quite a lot. So let's look at the design pattern itself. How does it work? Like I said, it's yeah, oh, yeah, I was explaining the observer design pattern. It's like YouTube, right? No, my bad, cancel. I want it's like YouTube. The people, the subscribers, those people who are watching the channel, we call those people observers. And then the thing that's being watched or observed, we call that subject. And since it's like YouTube, you can subscribe, right? Or you can unsubscribe, right? So we have two functions in the UML design, right? We have the attach method and the detach method. The attach method, you can view it as like subscribing. So okay, this was ComSci one. My bad. I'm supposed to close this thing. I was making a game of this first years. So let me close this, close that. And then this is not necessary. So the attach method, you can view it as like subscribing, right? And then the detach method, you can view it as like unsubscribe, right? It's similar to that. And then remember, there's also updating. Someone needs to be updated, right? There's an update somewhere. So yeah, let's do that. I hope I don't know. I'm not that perfect. I don't even know design patterns like that, but we'll see. I hope I can still remember some of the things. So we're gonna have an observer and the subject. So let's start with the observer first, right? So we have abstract observer, right? So what I would do, right? Um, it's fine. Yeah, it's fine. I actually let me think about it. Is that fine? Is that okay? No, let me not do that. You guys have the slides. Let me not reinvent what's on the slides. Let me not do that. You guys already have the slides. So what I would do is I'll actually update it. So we have what I call an abstract observer, which is the interface. So I'll actually put in a stereotype here so that you can see that it is an interface. So it's an interface. We call that, and it's going to be the abstract observer, right? Where the abstract methods and all the things, yeah, basically it's an interface and it represents our observer. So our observer in this case, let me see. When each monster enters the screen, okay, when each monster enters the screen, they're added to the list of monsters that they're that are observing the hero's health. List of monsters that are observing the hero's health. Okay, so that means we're gonna have to make it a list. Yeah, we know that for that much that this will be a list somewhere. So they said each monster enters the screen, they added to the list that are observing the heroes. Yeah. So the thing that's observing the thing is the monster. The monster observes the hero. But in this case, it observes, to be specific, it observes the hero's health. So whenever the hero's health changes, the monsters must also update their state. Decrease, blah, blah. You don't have to do that, right? Remember, this is not implementation, it's UML. They're just adding all that this extra information so that you really understand. So we say that our observer is a monster, so I'll call this one, okay, you don't have to put the keyword abstract, so I'll make it monster. I'll call it monster. You don't have to also make it I monster. No, you don't have to do all of that. Just call it a monster. This will be a name that makes sense. And then you're going to have two methods, right? Which take in remember, this is the observer, right? This should be the observer, right? You see this thing, not perfect. I hope it's, yeah, that's the observer, yeah. And then we have, yeah, that's the observer and then the subject. And I don't want to refer to the notes. But yeah, we have an observer. I think the observer is this. Yeah, I think we have the observer here, and then we have a subject there. Yeah. And then the observer, yeah, and then you have the attach and then detach and then the notify method. Yeah, and then the notify method. So this will be the monster interface, and then we're gonna put in methods. So we're gonna have attach, call it void. Uh, Attach, and then must also update the state. Where is it? Heroes out there added to the list of monsters that they're observing, blah blah. Okay. So attach, we need to pass in the thing. Yeah, so we need to pass in the thing that we are attaching. Basically, in this case, remember I said the attach method you can view it as like subscribing, right? In this case, who is the subscriber? Is basically is basically I think I made it. I don't know. I don't. My brain. I'm not that perfect with it. I know way. I'm gonna let myself suffer. Let me quickly. Let's look at that UML diagram. Yeah, I'm not gonna do slides. I should have done slides. Should have been better my own slides, but it's fine. So where's this thing? Hey, you see me and having a lot of things. Yeah, it's this one. 2022 slides. It's part one, right? I think it's part one. Then, yeah, yeah. So I messed it up. I knew something was off. So we have the subject, then yeah, makes sense now. So we have the subject this side, and then we have the observe on the other side. So the subject, yeah, which makes sense because the subject is the one that's subscribing and unsubscribing. So they should be able to subscribe and unsubscribe, right? So this is basically the monster class. So monster interface. And then here I'm gonna have attach method void. And then it takes in since this is the subject, right? No, my bad. No, this is wrong. It has to be hero. My bad. It has to be hero. We are observing the hero. That's the subject. My bad. So this is hero. That's the thing we're observing, and then attach. So we're gonna have two methods: attach and detach, right? So this is the wait. Yeah, this is the subject. This is the thing we're observing, the subject. So the subject, you see, it's kind of annoying when you have to think about the UML diagram on the slides and try to translate it. You get you get confused a little bit. So the hero is the thing, this is a subject, right? That's fine. And then the observer is the monster, yeah. So we need to attach the person. Remember, we have a subject, right? We need to attach yeah, which makes sense, yeah. So we have a subject which is like YouTube. This is a YouTube hero in this case represents your YouTube channel, right? Or your Instagram account. And then you have people that can subscribe or follow, unfollow, however you want to view it. So since this is the thing we are observing or the account we are following, right? We need to be able to attach a follower, right? Or add the follower or add the subscriber. So who's the subscriber? Subscriber is the person who's watching our channel, which is the observer. So we need to take in an observer. So new, okay, I need to delete one of these. Oh, delete, there's the keyword. So we need to take in an observer. So in this case, the observer is the monster. So I'm gonna take in monster, right? Because that's the observer, right? Remember, this is let me click apply. So this is our subject, the thing that we're observing. Obviously, it needs to be observed, right? So we're gonna attach an observer who's going to observe it, and we're gonna detach an observer who's observing it when he's done observing it. So attach and detach. Then here I'm gonna have detach, and they're both void functions, and then they're taking the same thing. The observer, the person who's observing the subject. In this case, the hero is the subject, the thing that the observer is observing. So we have these functions, and then we're supposed to, okay, click apply. And then we're supposed to have subject observer interface, which updates here. So here we're supposed to have, we also have supposed to have an update function also here, right? And then void. So this update function, right? You might ask yourself, what's the whole point of the update function? Oh, my bad, no extra round brackets. So this update function, remember you are the channel. You're the person that they're following, right? You can have followers, which is observers, meaning people can subscribe, attach. People can unsubscribe, which is detach. And then since people can now, let's say people have followed you, you can update your followers, right? You make a post. You tell them, hey guys, there's gonna be a concert in what stadium, FNB Stadium. So please attend. This will be the prices of the tickets, things like that. So you're updating your observers, right? In this case, another word, I feel like maybe English is a problem here. So let's say observer, view it as the word follower. It's like they mean follow, someone who's following you. So they can either decide to subscribe or follow. and then unsubscribe or unfollow. And if you look at it, think about it in a deeper sense. If you look at this attach and detach method, we said it's like following and unfollow, right? When you follow someone, don't you, when someone follows you, right, don't you need to know the person who's following you? It's true, right? So that's how you pass in the follower or the observer. And then when someone unsubscribes or unfollows your account, shouldn't it, let's say it tells you. So obviously, if it tells you who followed, you need to also know who followed, right? So that's why we pass in an instance of the person who's going to unfollow. So I hope that kind of makes sense to a certain extent. So this is the interface representing our subject. Then we're gonna have, remember it's representing our subject, the thing that's being observed. Then we're gonna have a concrete implementation here, right? Which implements this interface. So this will be, I'll call it concrete hero. Should Oh, I think it should be called hero because yeah, it should be called hero. You see, there's the yeah, I mean it's clear, yeah. It's going down here. These people they're not playing around, you know? Okay, I see. So hero, I think hero in this case, the hero class should be the concrete. Yeah, it should be the concrete class. As you can see, there it is. It's complete, right? It's concrete class. So that means the interface, I have to give it a different name. So I'm gonna call it abstract hero. Yeah. Let me call it abstract hero. And you see that I applied it to my problem. I didn't call it abstract observer. I call it abstract hero because my question is about heroes and monsters, right? And then this will be a concrete hero, or we can just call it hero, which should have an attribute, should have a state. Yeah, should have a state. I think the state represents this. Which state should we store? That's the tricky part. Oh, I think we store the state of the observer. Yeah, I think we store the state of the observer, and then on the other one we store the state of the subject. Yeah. So if you check here, they said when each monster enters the screen, right, they're added to the list of monsters that are observing the hero's health. So we're basically going to pass that list as the attribute, right? We suppose if you check on your UML, right, you're supposed to pass in what we call, I think, is it? No, I think it's not subject. I think it's observer state. Yeah. I think on the slides it's written as observer state. So we need to pass in some state, right? The state of the observer. In this case, who's the person who's observing? It's monster. And here they told you that they are a list of monsters that are observing, right? So I'm gonna make it a list of monsters. So I'm gonna call it monsters, and then it's gonna be a list of type monster. And then make it private, then apply. And then that's done. It's not, to be honest, design patterns, if you can remember the UML and when to apply it, you'll be okay. Because it's not too difficult to apply it to your problem. And then this should realize that interface, but we're not gonna do that yet. We are still on the subject. And then they said whenever hero's health changes, right? The monsters must also update their state, right? Yeah. So the monsters must also update their state. And then decrease, blah, blah. When a monster leaves the screen, if it is removed from the list of monsters. Some of the code has been completed, blah, blah. Okay. So, okay, I'm not actually done. This is incorrect because they gave you the class, right? They said hero. So you actually need to put these things in your UML. That's basically what they're saying. So we need to do that. So I'm going to take this. It's health. It talks about health, right? Okay, it's an enum that talks about health. So I'm gonna need to create that. So let me add those. So go back to my UML, double click, go to attributes, add another attribute. So we have data type, it's health, and then I'm gonna call it health. And they made it private, so private. Let's look again. And then we have a public function that basically the accessor for that attribute. So I'm going to create an operation for that. So it's called get health. It returns e-health, right? The e-hero health. And then, yeah. So now it's proper, right? And then now we go to the monsters class reference to the hero. Nah, yeah. We basically almost done with this. Yeah, we're almost done with the UML. So now we need to create the observer, the person who's observing. So I'm gonna go here. If you check the UML, the observer only has one function to update, right? Which makes sense. Right, let's see. Which makes sense because if you look at the question, the way they put it, that all the monsters must update their state. So that means there's an update function that's needed. They did kind of tell you that in the question paper, right? So they did tell you didn't have to remember that the UML for an observer design pattern involves an update method. They didn't have to tell you that. So I'm gonna create this class. So I'm gonna call it abstract. Abstract what monster. So abstract monster, and this is an interface again, and it only has one method, update method, right? And then void. Let me see. Did I? Yeah, that's fine. Yeah, only that method should suffice. So there's that update method to update, right? And then to update its state. And then here we have the concrete monster, which is just the monster. So I'm gonna double click on this concrete monster, which is just monster, and this will be a class. And it has attributes, which is the state, right? Remember, we have observer state and subject state. So the what is it called again? The observer, the concrete observer takes in the subject state. Yeah. If you look at the UML. So this will be hero, which is the subject state. Remember, the subject is the thing we're observing, right? In this case, is the hero. So we need to have that there. So hero of type hero, make it private, and then apply. And then what operations or functions do we have? Oh, we still also have action. So let's also add action. So e monster action. So I'm gonna add another attribute here. So it's called action. It represents the action. And then private, apply, and then operations. Yeah, there's no extra operations. Okay. So that means the only operation we have here is the update from our interface that we're gonna realize. Remember to basically extend an interface. We call it realization of an interface. So we implement that method inside this concrete monster. Then yeah, so these two, right? This is supposed to take in, let me think. This is supposed to take in actually an abstract monster, technically. Yeah, but it's fine. I think it's supposed to take in an abstract monster. So let's realize the interfaces. So it's not association, it's this one, right? So you realize or to implement the interface, remember, use the keyword implements. So to implement the interface, you need that symbol. And then we need that symbol again, the side. I think it's supposed to be abstract monster and an abstract hero, something like that. But it's fine. Oh yeah, it doesn't necessarily have to be abstract. Yeah, because here they use the actual hero. Yeah, it's fine. So this diagram is fine. So here we have this monster. Yeah, so this monster instance, right, is associated with this interface. So we need to do association here. This is associated with this, right? But I'm not sure about the direction, but I think if you look at this triangle, right? The direction is pointing to right. It means that if it's pointing in that direction to the right, it means this one is the one that's associated with that, which is not really the case. I should change the direction of the triangle. So I'm gonna double click on that line and then I'm gonna go under direction. And then I'm gonna click, instead of from A to B, I'm gonna choose from B to A. Then click apply, click OK. So this is associated with this, as you can see, because it's passed as a parameter here. And then hero, let's see, hero. Yeah, it's composition, right? As you can see, it's composition or aggregation. It's up to you what you want to call it. Composition or aggregation. So this from here to there. But it kind of feels wrong, man. Because in the shouldn't it be? It's fine. I think we could have used the abstract monster if it was a base class. In this case, it's only an interface. Technically, you can still use it either way, but I think it would be better if it was an abstract base class or a base class. Then we can say of type base class here. So it's fine. We'll just leave it as monster. And then here, I'll just change this to composition. It's up to you. You can sit down and think about it and be like, okay, is it composition? Is it aggregation? You can think about that. Basically each hero has a list of monsters. Basically I think a list of monsters that they defeat or something like that. So the question is, can the monster exist without a hero? True, it can exist without a hero. So to be honest, it's more correct to say aggregation than composition because there's no life cycle dependence, meaning they can both exist independently. So yeah, I would choose, I think aggregation would be more correct. So I'm gonna export this as a PNG, SVG, yeah, SVG, it's fine. Then this is observer design pattern. Yeah, I think the diagram should be okay. Yeah, I think it's okay now. So yeah, most of the things, let me see, let's do another question. Says the same relationship between most of the things are it's nodes. See this part over here. I'll leave that to the slides. The slides explain better there. Hopefully, hopefully they do explain better. Yeah, hopefully they do explain better. So give binary IO, provide a reason for answers. Which members cannot be serialized? Okay, so let's start it from the top. Let's start it from question 2 then. So I'm gonna start from question 2. Yeah, let's start with question 2. So let me open Microsoft Word so that I can save the answers and convert it to a PDF when we're done. Yeah, but binary file should be file handling for you guys. You guys should be comfortable with that. We did past papers on that. Question 4. Okay, so also have question 5. Question 4. So we were doing question 4 for the UML. So this is question 4. Then question 4, I'm going to insert that diagram, which is on the desktop or downloads. Why is it so slow now? Okay, I think it's on, is it desktop? Where is it saved? Just give me a sec. Where did I save it? I don't know. I'll edit later. I don't even know where I'm saving my things. Let's just go straight to question 2. I'll add it down there before I send you guys the solution. Okay. Yeah. So let's go to the next question. So given the code below, which members will not be serialized? Provide a reason for your answers. I don't. The thing is on the slides. There's no. If you check on the slides, there's no like extensive explanation. Last time I checked about why the static and transient are not saved. Static, it makes sense. You can explain it because static. Remember, static. It means that it's not an instance, and in the file we are saving instances, right? So everything we're saving every object we're writing to a binary file, it's actually a specific instance. And when you use the keyword static, remember static, you can only call other things that are static inside of that thing that's static. So that means that we won't be able to write that thing to the file. And like I said, it belongs to the class, not to the instance, because static means it's part of the class, not to the instance. And writing to objects to a binary file, you write actual instances, not the class itself. If you get what I'm saying. Because the class is just the template, just the plan. You don't write the class itself. When you say implements serializable, you're basically saying every instance of this class can be written to a binary file, not the class itself. You don't write the class to a binary. There's no such a thing. So yeah, so for static, it might be kind of easier to explain. Transient, not not familiar with that. I don't see it on the slides. In the slides, they just list. They just said these are the ones that are not written. Last time I checked the slides. So static, when writing to the binary file, you write actual instances to the file, and everything declared with the static keyword means it belongs to the class, not the instance, not the instance, right? So therefore, that's why we cannot write it to the file. So they said, did they say? Let me see. What did they say? Oh, which members? Oh, so it's actually not too deep. I'm actually explaining it way too deep. They said which members. So you must specify which variable. So I'm gonna say the variable here, it's the one that's written real estate. And then this will be one of the reasons, right? Another reason would be static members cannot be written to a binary file. Yeah, I think they don't want, because on the slides I don't see it going into deep. And then what's the other member that cannot be written to a file? It's char state. That's the name of the variable, char state. They said member. They didn't talk about data types here. Transient is it's not necessarily a data type, but it's what we call an access modifier. It's not a member. Char state is the member of the class. It belongs to that class. It's a variable of inside of that class. So that's why I'm referring to variables, because that's what the question wants. So char state, why can't you write, why won't it be saved? Because transient variables cannot be written to a binary file. Because remember, there's marks for choosing, and then there's marks for just short explanation. So yeah, I think this should suffice, because on the slides it just says if it's static, you cannot write it to a file, to a binary file. If it's transient, you cannot write it to a binary file. So just use what the slides say. I think even in the textbook, it just says static and transient. It doesn't go into too much details. Mm, okay, so analyze the following Java code segment and answer the questions that follow. The code shown above does not compile. Indicate the lines where problems occur and provide Java source code that will correct the problem. So if you read this question right, it's separated, it's divided into two parts, combined by the keyword and, right? That's where we get the conjunction, right? Let's read before the end. It says indicate the line number where the problem or problems occurred. So you need to indicate those line numbers. So if we check here, yeah, I think the only line, yeah, the only line number that's gonna cause a problem is line 6. And then they said provide Java source code that will correct the problem. Yeah, so mention the line. It's line 6. You might not understand why, because like I said, I know you guys have a lot of modules, but reading the textbook helps you a lot, Shem. Here, the problem, right, is that in Java, it's not allowed to pass primitive types when you're calling something that's generic. So for example, this is a generic function, right? So obviously we need to specify what type is T, what T is, right? So that we know it's an array of what type. And then here they use int to say it's an array of integers. But Java disallows passing primitive types. I think we did talk about this. So you need to pass in what we call wrapper types. So the problem is indeed line 6. And you need to look at the line number. It's line 6, right? So I need to write it down and say, question 3, the problem is line 6, line 6. And then the solution. So what's the solution? It's basically redeclaring the whole thing, right? The whole variable, the whole array. But instead of passing int, you pass an integer. Notice something here. You need to understand the question. They said indicate the line number where the problem occurred. That's the first step. And provide Java source code. They didn't say explain. That's the main thing I want you to understand. They didn't say explain. They just said fix it. So line 6, and then that's the code. Instead of int, I'm gonna say integer, like that, right? And then everything else is fine. Yeah, everything else is fine. The only thing that needed to change was this. And if you look at the code, right, there was no need to say test generic dot. Oh yeah, no, yeah, there isn't. You can just simply call the function as it is. But then they were being too extra here, and then they did that. But it's fine. I don't really care much about that. So we have question 4, which is the UML. We did that. So I'm gonna do this. I'm just gonna write question 4 and then leave some space so that when I add the UML, let me just edit. I just want to be, because I might forget and get caught up with something else. Where is it saving these things? Okay, it's fine. Let me choose an. Oh, I think I didn't choose the location. I think that's what the problem was. So export, save it on desktop. Yeah, I didn't choose the location. And then now I can insert. So pictures, this device, and then desktop, diagram 1. There we go. So there's the diagram. Okay, let me click here. Then we go to question 5. I think question 5 is it the last question? I think it is. This question paper is short, Thomas. See if you know your stuff though. If you don't, you're cooked. So let me use Notepad for writing this answer for the cold code. So let me delete this and then change the language to Java so that it highlights. So that when I take the screenshot, you guys can see that this is written in Java. Provide question 5 code. Provide Java source code for the following problem. You can assume that all relevant packages have been imported. Create a most radioactive material method that accepts a file handle, and it returns a radioactive material with the highest radioactivity. So you need to create this function first. So let's break it down. So they said create a function with this name, right? So I'm going to copy this name, and it returns a radioactive material, right? So, and they said it takes in a file handle. So file handle, right? And then it returns the radioactive material. So I'm going to copy all of this name, put it right before this, like this, right? So you don't have to worry about things like public, whatever. You don't have to worry about that. But I'll just use the public access modifier. So there's the function, right? So, so radioactive material, most radioactive material takes in a file handle. Yeah, that's correct. So yeah, so it takes in a file handle as a parameter, and it returns a radioactive material with the highest radioactivity. So we need to find the highest one. So since we need to return the is do you understand what it means, right? They said the radioactive material with the highest radioactivity. So we need to find the highest. So we're finding maximum here. I don't know what type is radioactivity. So let me close other things here. Exit without save. Yeah, so let's see what type is radioactivity. You see radioactivity is of type double. So that means the maximum is stored in a variable of type double. So I'm going to say double. I'm going to call it highest radioactivity. That would be a too long name. I'll just call it highest. And then remember our technique, right? Why do I, you might ask yourself, why do I choose that approach? It's just the personal preference. So if you're finding a highest, so I would advise you to always initialize it to the max, to the minimum that data type can represent. Because if you're finding the highest, that means if you initialize it to a very small number, this variable has a potential of being changed. The problem is if you initialize it to things like zero, for example, let's say, okay, let's not say we're finding a highest, let's say we're finding a lowest. And you had the bright idea of initializing it to 0.0, right? Let's say in your file that you're reading from, these are the numbers you have. You have 33, 12, 10, 8, 2. Do you see that the answer here should actually be, the lowest should actually be 2. But for some weird reason, it's going to say the lowest is 0. Do you see the problem with that? That's why if you're finding a lowest, you're going to initialize it to the maximum a double can represent, because that's a very big number, meaning it will definitely be changed or updated. And then vice versa, if you're working with looking for the highest. So that's why, if you remember that code that I wrote, why I was initializing to what the integer.max value or integer.min value. So this is highest, and then this will be double, which is the wrapper class dot its highest, so min. So I'm going to initialize it to the smallest possible number. So it goes to double dot min value. Then this is the variable that's going to store the highest radioactivity, right? The radioactivity, which is that double itself, the radioactivity itself, right? Then the material, which material is the highest? We need a variable for that. So I'm gonna create a variable for that, radioactive material, because remember the function is supposed to return that radioactive material. So we need to declare it. So this is the highest material. I'll just call it highest material to keep my code more understandable, right? So I'm gonna need to return that highest material at the end of the day, right? I'm so used to saving. Now every time I make a few changes, I save. So let's see. So they said you are reading from the binary file, right? So reading from the binary file must make use of ARM, which is the automatic resource management. The number of radioactivity is written as int at the start of the file. This is actually kind of bad in a way because they didn't tell you whether it's like objects or you get what I'm saying. They didn't tell you, but you see that you need to kind of use your common sense here. They said the number of radioactive materials, meaning objects. So here we're using the object input stream, not the data input stream. So, and we must use the ARM. So I'm gonna need a try catch for that. So try, and then inside the parentheses, right, the round brackets, I need to instantiate. Remember, this file handle, this file class does not have methods to read and write. So I need to pass it via the file input stream. I'm going to call it fin is equals to new file input stream, and then we pass in our file handle, and then put a semicolon there. Still within the same round brackets for the try catch. I'll obviously put these curly braces point here, and then let me just catch the exceptions. I know one of the exceptions is file not found exception, and then the other one is IO exception, right? Input output exception. And then here it's fine. I'll just say e.print stack trace. And then the other exception that might occur is the IO exception. EX, because we already have an exception called E here. I don't know if that affects anything. I haven't tried it out, but I think it does affect. It should use different names. Yeah, so that's the try catch. So let's continue. So after passing it into the file input stream, remember the file input stream only allows us to read the bytes, right? Which is the zeros and ones. So we need to wrap them around the actual types, whether that's an object or a primitive type, reference or primitive type. But before we do that, we need to buffer it first. So buffered input stream. And I'm using, I don't see the need to explain this, but I'm going to explain it again. I'm using buffered input stream because I'm reading. So it's the same thing as input if you're reading from a file. So that's why I'm using the input stream, not the output stream. Buffered input stream, then semicolon, then we pass in the file input stream, which is declared as fin, right? And then after that, we declare our, remember that they did tell you, we need to declare our object input stream, not data input stream. Remember, data input stream, it's only for primitive types. Even though in the question paper, they did tell you that there is the number of radioactive materials at the start of the file. They're telling you that so that you know how many objects you're going to read. So that's why they told you that. And remember, we talked about it, the object input stream class has methods for reading both an reference types, which is objects, and primitive types. It is both methods. So we can read an integer and objects. If you knew. If you didn't know, you'll be cooked. So as it goes to new object input stream semicolon, and then you pass in our buffer because we've buffered it. It's in that buffer, so we read from that buffer. Then now we start by, remember they said at the start of the file, we have the number of radioactive materials. So read the number of radioactive materials because it's at the start of the file. And we know it's going to be an integer, so int number of radioactive material. This is long. I'm gonna call it number of materials. That name is too long. Number of materials. Keep it simple. And then, okay, let me not call it, my bad. It's object in, not data. Data, I usually use data when I have a data input stream. So here I have an object, so it's gonna be prefixed as obj for object. So obj in dot read an integer, read int. Then now, since we now know how many objects to read, why is that important? Because that's important. The reason why that's important, right, is because the read object function, right, this function, it might throw an exception if you try to read an object that's not there. So it's a binary file. It's in the language of the computer. How will you know how many objects are there? That's why before they give you the file, when they write to that binary file that they gave you, they start by writing the number of material so that you know how many times the read object needs to be called. So that you don't call it more or less than the actual number of times you should call it. So I hope that makes sense now. So now um, we read all the materials. But you need to do a follow for that because we don't know how many times we're going to have to call the read object function. So we just use this number that we were told, which is the number of materials. So this goes to 0, I is less than number of materials, I plus plus, and then we can read from the file, right? So we need to read the material. These people are very misleading. Do you know that I've been doing there's people, yeah, and these people want you guys to fail this much. Do you see the mistake that I've been making? Yeah. Yeah, you see the mistake that I was making. They're they're saying the radioactive material, but there's no class named radioactive material. It's actually named material. So yeah, I know a lot of you guys would have been chopped by by that question by now. And you're gonna come out confident. Oh, we killed it. Oh, that was easy. And then someone decides to say, what was the answer for 3.1? That's when you start sweating. And you're the only one who got, imagine people are getting, let's say the people are getting the answer, let's say it's maths, people are getting answers like 1, 2, 0, -1, and then there's you got 340,000 for that question. That's when you know you really cooked. So yeah, make sure you read the questions properly, right? Like read them properly. They did actually give you the class here, which is this is very misleading. Because usually they tell you the actual type here, they write it there. Here they just said, yeah, and a lot of students fail this question paper. I know for a fact. A lot. So let's continue. I need to fix that. It's material, not radioactive material. It's material type. So let's read the object, right? So we know that it's going to return something of type object. So I'm going to store it inside, I'm going to create a variable of type object because the read object function returns something of type object. Then we check what data type is that object by using the instance of keyword. Then we cast it to the right instance or to the right type. So I'm going to read the object and then I'm going to check if it's a radioactive material. So if it's radioactive material, so basically if it's a material, so check if it is an instance of the material class. So if this object variable over here is an instance of, meaning it's of that type. What type is it? Type material. That means I know that I am 100% sure I found a material. Then it's safe to cast. Which you might ask yourself, what's the point of instance of? Because we want to make sure it's safe to cast and your code doesn't crash. Because Java is remember Java was made to improve C++. C++ would let a lot of things slide. C++, it follows that philosophy of trust the developer. The developer is a genius. That's C++. Java, it's like the developer is the brain of a mouse. So let's make sure they check everything thoroughly before they run they check for nulls, if it's null. So Java tends to have a lot of those checks. The thing is, if you don't check them, it also crashes. That's the thing. So instead of before you cast, you need to check if it's of that type, right? For example, you can't convert You can't convert a mouse to a car, right? To a Ferrari. You can't, right? So that's exactly why we need to check if this is a mouse, so that I know it's safe to convert it to a mouse, because I will actually get a mouse, not to try and convert to something that makes no sense. Don't do spiritual things here. So let's convert it to material. So material, I'm gonna call it material in small letters, goes to okay, we need to cast it. So round brackets, we put in the type we want to cast it to. We put the type we want to cast the object to inside round brackets. So we want to cast it to be of type material. What instance is that? It's the instance named object, which is this instance over here. Then now we have the material stored inside this variable called material in small. Man, look at the case that I've used, right? These are all small letters. This is capitalized to show that this is a data type. So be very careful of that. Okay, they'll mark you obviously, but in the future, especially third year, they don't have time for that. They don't have time for nonsense. They'll mark you wrong if it's wrong. So reading from the binary file must make use. Yeah, we are reading from the binary. Yeah, they said, remember that they said you need to find the highest, like the radioactivity, right? Since what I will do, right? Remember we have the highest material here. I'll just initialize it to null for now, so that it at least it's initialized, because the main important thing is to initialize it. You need to initialize it. So we need to find the highest activity, right? Or radioactivity. So it's the highest radioactivity will be stored inside the variable called highest. The actual highest. I don't want you to get confused. By by radioactivity, I mean the actual variable. By radioactive material, I mean which instance has this highest radioactivity. So I hope that doesn't confuse you guys. So let's check. So we need to check. Remember the way we do minimum or maximum, we start with an assumption. We start with the first value. Here we assumed that our highest or the biggest thing that we have is the minimum of a double, which should be 0.0, I think. No, it's not 0.0, it's minus 3 point, yeah, something. Yeah, it's not zero, yeah. But it's fine, you don't have to know about those details. So we assumed it's some number. That's the highest. So we need to check if our assumption was right. So check for the highest radioactivity material, or highest radioactivity, not the material. So I'm gonna check if my highest, right, basically the previously assumed highest, is actually less than this current material's radioactivity. Because remember, it's of type double. We are comparing the radioactivity values. So we need to check what access, what is the accessor called. That's why they gave you this class over here. So that when you call functions, you know which functions to call. So I want to get the radioactivity. So this is the function, it's called get radioactivity. So remember, we are reading from the file, the material. So each material that I read, I store it inside this variable called material. So that's how I'm going to say material dot get the radioactivity for that specific material that I've read from the file. And then I'm going to check if it's, like I said, you can do it in any way. If you read it from right to left, it means the radioactivity is greater than highest. If you read it from right to left, if you have powerful imagination skills. So you can actually rewrite this like this. For those who don't have good imagination, you can say if this current material that I've read from the file, its radioactivity, that's denoted by the dot get radioactivity, its radioactivity, if it's greater than the current assumed highest, then that means I was wrong. My assumption was wrong. So I need to update the highest to be equals to that current radioactivity that I've read from this current material. But I also need to keep track of which material, meaning the instance, which instance had the highest radioactivity. So within that same if statement, immediately when I'm done updating the highest, I need to also save which material stores the highest. That's why I created that variable on the outside to this one. It keeps track of the highest, the material with the highest radioactivity. Then I'm going to say highest material is equal to that material instance. And then you're done with your function. And then, yeah, that's basically it. And then they said you should return the instance to the highest. Yeah, and then you're done. That's pretty much it. They said you return the radioactive material with the highest radioactivity. So the mission has been accomplished now. There's nothing more to do. So I'll zoom out a little bit. Yeah, and then copy this, take a screenshot from here into here, right? Then I'm gonna go here, question 5, right? And then paste it. Okay, yeah, it is readable. Yeah, at least that I thought it wouldn't be that visible, but yeah, it is visible. Yeah, so this is how you solve question 5. And then that's pretty much it. Question 1 now, you guys will go solve that. But I'll just explain it, I'll just talk about it a bit. So application, if I'm not mistaken, I still remember kind of some of these things. If application class, right? It basically it basically allows us to create a JavaFX application. So the role of this class, right, is that its role, I will put it in this way. The role of the application class is that every application that wants to use JavaFX, it should extend this application class in order to use JavaFX. So that's its purpose, that's its role right there. And then the stage is basically like a stage, like a stage when you go watch a play, when you go out with the family or with the partner, or with the friend to go watch a play. A play is like, for those who don't understand, it's like, remember about Romeo and Juliet, all those things in high school. Remember, there's actual plays for that where people recite the actual books. Yeah, so those plays, that's what I'm talking about. So that stage, right? The stage just gives us sort of like that stage, like a platform for us to add the we call them nodes, right? It gives us a platform to add the nodes that will form part of the JavaFX application. Um, yeah, or maybe it's the scene. Let me see. The scene is on the stage. Yeah. So in order for the stage to be there, right? That's the thing. In order for the stage to be there needs to be a scene. For example, you wouldn't want to go watch a play when there's no actors, right? Basically, there's no scene. There's nothing to see. You wouldn't want to go watch that play. So the scene is very important because without the scene, there can never be a stage. That's the thing. If you noticed, let me open this code. If you notice no, it's fine. Let me not open it. Let me leave it. Let me not look at that code. But if you looked at your practical, right? The which part is that? The main.java. If you noticed, in order to the stage, if you don't set the scene, the stage won't show. So there's a code dependency between those two classes. They work hand in hand, right? They work together. You need to add a scene, right? And that scene will be added on the stage, or that scene will be performed on the stage, right? So the stage you can view the stage as like, you can describe the stage as like a container of scenes, right? I think that's the best way to explain it. And then the scene is the definition that I previously gave for the stage, which basically means that the scene gives us a platform it gives us um not necessarily, it gives us like it gives us a place where we can add the nodes that will be that will be seen on the stage. By seen, I mean that seen SEEN, not I don't get it confused. I don't mean the scene. And then they also they did say explain the relationship between a stage and the scene. The scene is shown on the stage, and then the stage holds a scene, right? The scene is added on the stage, and then the stage takes a scene, a specific scene, and then it shows the scene, right, on that specific stage. And then, yeah, this is slides. Anonymous inner classes. Anonymous inner classes is very deep. The definition I'm going to give is very deep because anonymous inner classes, yeah, let me not. There's anonymous class. There's not anonymous. Java is too broad. Because I remember I was learning something. There's something called. That's why I said if I talk about it, I'll be going into deep. There's something called SAM. Yeah, something like that in Java. Single abstract method approach, something like that. That's what comes to mind. But let me not. That's why I say just go on the slides for this. How an anonymous inner class can be used in Java FX for event handling. Yeah. You see this question over here, the question number 3. It talks about this same thing, like single abstract method. So basically, right, there's something that we call an anonymous class. Basically, it's a class that doesn't have a name. What do you mean by that? So for example, it's like I won't go into the details, but if it was possible, imagine you have shape like this, right? You have that class shape, right? And then inside your main.java, somewhere along the lines, right? You're allowed to have anonymous in a class. So you can just say new shape. You see that you just created a new shape, but it has no name. By no name, it means that we didn't initialize it into a variable. If we initialize it into a variable and we call it shape2, it's no longer anonymous because we can refer to it via shape2. But if you remove this part here and just simply say new shape, it becomes anonymous because it has no name. And with interfaces, you can achieve that through this same approach, but that's not that's too advanced. I'm not gonna talk about that. I think they just want a simple explanation here. So just go look on the slides for a simpler explanation because I really understand what's going on behind the scenes here. JavaFX, it actually uses that thing. It's called SAM. So with SAM, it can allow you to create what we call anonymous classes. By a single abstract method, right? They just mean that you create an interface with one method in it. Then that's one of the conditions that need to be met. If it has a single abstract method that interface, then you can create anonymous classes. And if you can do this, you can also end up doing what you call, since it's anonymous, you can also create lambdas through them, right? So instead of new shape, you can just say maybe um, call it S for shape, and then put an arrow like this. So this is now applying what we call lambdas. But you'd have to actually go look at the slides for that. So I'm not gonna go into deep in this because it would take us maybe an hour or so explaining that, and of which is not necessary. I've actually learnt it after UJ, not at UJ, so it's not necessary information. So yeah, that's it for today's session. Yeah, just make sure you study the slides. And most of the things though, they'll come from the slides. Don't bring anything new. Just know that. Don't bring anything new. They'll come from the slides. So I'll send you guys the solution in the group chat after this session. So yeah, okay, let me stop. Okay, it's fine. I'll continue recording. Yeah, what's your question?
Someone sent a question there by the group. I think they want you to go through question 5 of 2024 paper.
That's if I know the design pattern. Me right now, the only design patterns I know is observe and visit. But let me stop sharing my screen quickly and check if we can do it now. So let me download it. Someone sent me the question paper, ne? Yeah, someone sent it. Let's see. So let's see. Where's the question paper? Somewhere there. Okay, there it is. 2024. Oh, I already did download it. Okay. Let me share my screen. As if I know the design pattern. I, I don't know. People think I know. I have everything in my brain. My brain is it can be trusted with it. My brain, yeah, I forget these things. I'd have to actually prepare before the session. Just not prepare per se, just to brush through, to remember the things. Sometimes I have to actually read the textbook because I can't possibly remember everything because I'm also studying my own things. Especially and I recently joined the FNP thingy, so I'm gonna be busy with that. Mm. Okay, describe 22 helper classes in Java FX. Wanyiwa mo. You better go study. And third, okay, this is just code. Yeah, I checked. We did talk about checked and unchecked. You have to go and rewatch those recordings. We did talk about that. This, totally forgot about that. Yeah, I don't know about procs. I'd have to actually read about procs. Yeah, the other questions are simple. I think though you guys, the only thing that's challenging for you guys is the design patterns. It's fine. So I'll think about what time are you guys writing tomorrow? Are you writing in the morning or during the prac session? Prac session's time. What time are you writing?
During the prac, I think, yeah, 2.
Okay, then it's fine. We'll only do question three. Is it question five or question three? No, it's question three because there's no question five. It just be question three at the
No, it's question 4. It's question 4. They screenshotted the thingy. Yeah, it's question 4.
the one question four.
Yeah.
Uh, we can do question four because I know it. But then this is okay, analyze the humor class diagram. We did something similar to this. Like I said, yeah, the thing is, I want you guys to go focus on studying now. We did yeah, we did cover this. There was exactly a similar question. Let me read. What is this about exactly? ARM, one parameter tab must be separated tab character. This is different. It says write to the file. That is pretty straightforward, but it's fine. Let's do it. Let's do the question. It's fine. Let's answer it. They said question four, this question over here, is this the same thing?
Yeah, it's question 4. Yeah, it's question 4.
Okay, let's hope we're answering the right question. So code, analyze the year mod class diagram, provide Java source code for the following problem. So we're gonna use Notepad++ again. So we have write to hotel file, takes in a file handle and a hotel, and it returns Boolean, right? That's what that function takes in. So let's see. Don't even know what this means. Hotels is requested that you assist them with processing the data for their hotel management project. In order to accomplish this task, you are required to create a write hotel to file function, which is this function over here. They did give you the function signature. We call that the function signature. The write hotel to file method found in the hotel file handler class. Yeah, there's the class. Yeah, the method signature must match the one in the UML provided. Is like I said, it's called a method signature. They said it must match with the one in the UML. So I just need to copy this. So since I'm very lazy, I'm gonna copy this. You guys are gonna write it on a piece of paper, so you can copy paste. Since it's theory, so I'm gonna paste that there. Yeah, this is code is different from YAML. You need to change the order around. So it's file handle like this. And then a hotel here. Yeah, you can only copy and paste if you know your stuff. If you don't, you're gonna have issues. And it returns a Boolean, so the return should be right before the function name. It returns a Boolean. I'll just also make it public. All right, yeah. So make it public, Boolean, write hotel to file. Okay, so we are writing to the file. If it's, remember, talked about it, it's on the slides too, if you didn't know. To write to a file, if it's a text file, use a print writer. If it's not a text file, obviously that's binary, right? Meaning if it's binary, you can use data output stream or object output stream, depending on whether you're writing reference types to the file or primitive types. The write hotel to file method must use the ARM and any exceptions must be handled in the method. So it must ARM, exception handling, blah, blah, all that. So let's do that. So we need to use what we call a print writer. Print writer works exactly the same as system.out. Exactly the same. The only difference is that you're writing, that's whatever you pass inside the print line or print or printf method. It's no longer written to the console, but it's now written to the file. So there's actually nothing new there. You notice in the code, there's nothing new. So we need to use ARM, but before I do that, I'm gonna put in the exception, catch the exceptions. So we have file not found, exception, right? And then catch IO, exception, EX, and then we print the stack trace. And then print the stack trace. So EX dot print stack trace, right? And then here we're going to instantiate the thing we're going to use to write to the file. Remember, we're not reading from the file, we are writing to the file. So we use what I call a print writer, something that actually creates a reference type. So we'll be able to call methods. So it's print writer like this, capital P, capital W, print writer. I'm going to call it out so that you see the pattern. So out is equals to new print writer. And then you pass in the thing you're writing to. So I'm writing to a file. So I'm going to pass in a file handle, right? And then now I need to write a file here under the try block. So the method, right, it must write all the rooms found in the hotel parameter per line. Per line, they mean you need to use print line. Whether it's up to you whether you use printf, but it needs to end with a line feed, right? With an end of line character, \n, or whether you use print line method, it needs to end with that. So basically, each thing needs to be on its own line. And they said attributes must be separated with a tab. Correct. So me, I'll do it in my own way, right? I'll show. The thing is, students like to cram. Should I do it in using print? Let me use print line. It's fine. Let me not use printf. I could have used printf. Printf also works. Even print line using, yeah, there's a lot to Java. That's the problem with Java. There's a lot you can do with Java. There's quite a lot. So let's see. with the type carry. Additionally, if it fails for any reason, then the method must return false. Otherwise, if all goes well, then the method returns true. So the question is, how do you know everything went well? Yeah, if everything went well, I would say that every line under the try block is executed. That's when you know everything went well. And this is the try block. It starts at this curly brace over here, and it ends at this curly brace. That's the try block. So what I can do is I can return false at the end here, down there. By default, it returns false, meaning if something goes wrong somewhere here, it'll go down here and return false and fail, right? Meaning something did go wrong. Wait. Let me think about it. They said, no, let's think about it. If writing fails for any reason, then the method must return false. So I'm gonna switch it up a bit. I'm actually gonna change this to true. So if we get to this part, that means it is true. Everything was successful. How do you know writing to the file failed? Remember, if anything goes wrong, it throws what we call an exception. So that means that I simply need to come here. Instead of saying print stack trace, I just say return false. Because it means it failed to read from the file. Same applies here. Return false. So it actually wanted you to be very clever here and use common sense. I know you might be like, I know some students will be like, how do you know all the answers? No, I don't have all the answers. I just read the question and used my brain. There's nothing special about me. I just looked at the question and I just chose to do this approach because it made sense to me. You could have chosen another approach, that's fine. That's your approach. There's no one right answer. There's more, Java is broad. There's multiple answers that you can write for one question. And then otherwise, if all goes well, then return true. And then they said, note, only the right method is required to answer this question. It's basically, they want you to get shocked when you see 15 marks. Just write that one function. They say that it should be sufficient. They should write all the rooms from this hotel parameter. Remember, we take in, okay, let me close this. Uh, yeah, remember we take in a hotel, right? Which is the instance to save, or the hotel that we want to save to the file. That's what we take in. But then remember, each hotel has a specific number of rooms. So so we have, okay, this a specific number of rooms, right? And it's private. You see, they're testing whether you're attending classes. You see, there's a minus here, meaning it cannot be accessed. It's private. There's a plus here, meaning these are public. So we have what we call a get room count, right? I'm assuming the get room count, it returns the number of rooms that are there. That's the only thing it can possibly mean. So that means we can get the number of rooms that are there from this hotel. And remember, these are all instance variables, right? So we're gonna go to that hotel instance. We call the get item room count, which returns the number of rooms. Then we go through each of the room. Remember, arrays has zero index, so we're gonna start counting from zero. So I'm gonna go here and say go through all the rooms. Then for int, I'm just gonna use R for room. Doesn't matter, I can use any letter. I'm just gonna use R. While R is less than instance to save, which is the room itself, right? Remember the hotel, I mean, the hotel is called instance to save. So instance to save dot get room count, and then R plus plus. So we go through all the rooms, right? So they'll be stored inside this variable R, all the rooms. So that means I can get the specific room that I want to write to the file. And if you check here, this is going to be, it is testing your Java here, your Java skills. Let me think. They said everything is on a specific line. Okay, I see. So I see the code. Yeah, I have this. I'm at the level now. When I read a question, sometimes I can actually solve the code in my head. So I know how the code should look for this. So let's do that. So we need to get the room first. So I'm gonna it's gonna return a room. So I'm gonna say my hotel instance to save dot get room. It's called get room, right? Yeah. And then you pass in the index or the way which room you want to get. And all of the rooms are stored inside the variable R. So I'm gonna pass R there. Then I got in the room. Once I have the room, in my UML, they told me which accessors that I need to use to get those things. So each room has a number and a price, and we can get them via these variables. So we have one string, one double. I don't have to worry about that too much because the approach that I'm using won't force me to understand the types. And they did tell you something here, very important here, attributes or variables. Another word for attributes means variables. They are separated with a tab. Tab is backslash T. So let's print it, right? Let's write to the file. So if you remember system.out, I could say system.out dot print line, right? Like I said, it works exactly the same way. The only difference is that you're now printing to a specific file. That's why you pass in a file handle there. Then let's write to the file. So we have number, get number, and get what? What's the other one? Get price. So get number and get price. So I'm gonna start by printing the number, right? So I'm gonna say, okay, look, it's a text file. I mean, it is cool. It's fine. You can add strings there, but let me not add strings. Like, let me not add labels. Like this, right? Let me not say number, colon. Let me not do that. They didn't say that. So I'll just say the room, right? We just stored under this variable or that instance dot get number, and then plus a tab backslash T, right? And then plus, because I said everything is all the attributes, they are separated by tab, plus room dot get price, right? And then, yeah, and then they said, if you look at the question paper, they did tell you that addition, where is it? Yeah, they said all rooms found in the hotel parameter, one per line. So you must end with the backslash n or a line feed. In this case, this function does have, it's called print line. So it does add the line at the end. So yeah, this is basically the solution for that question. That's all you needed to do there. I don't see anything more. Oh, okay, we're not done. We're not done with the false part, the true or false. If everything, okay, let's check. No, we're done. Yeah, we're done. Because if everything goes well in the try block, right, that means none of the catch blocks will be executed. So it's gonna go straight to return true, which is true because everything went well. And then if for some reason something goes wrong, basically an exception occurs. We return false, meaning the file writing to the file is failed. So this is, yeah, it's weird. Imagine all this short code for 15 marks. So that's what happens when you know your stuff. You don't have to stress about these things. You don't have to write spiritual things there. Hey, yeah, and then some people are gonna write spiritual things tomorrow. Hey, it's gonna be so spiritual that they'll say, "Hey, go watch that guy. What's that name? Sadhguru. Go watch Sadhguru." Mobile seems like when you wanna dwell, you wanna touch on spiritual things. So this is question for the 2021, 2024 paper right here. This is the 2024 paper. So that you don't get confused by the diagrams. So you don't think it's part of the same question. Yeah, 2020 ST3. Sorry, ST3. Yeah. So this is the solution. So yeah, at least his question is answered here. So yeah, that'll be all for today. Good luck with your test tomorrow. I hope you guys make me proud and you don't write spiritual things. And you're out there trying to, they say write these objects to a binary and you start using print right. I yeah, let's hope you know let's hope the Mr. What's this guy? Mr. Magnalal or Mangalal. I don't know how you pronounce his name. I hope he doesn't get mad